Okay, this is a recap of what we did in class, section 5.10, factor by grouping. And the first problems just get you used to looking at a factor that's a binomial instead of just a single number or a single variable. So when I look at number 1, I can see that x minus 2, or the binomial x minus 2, is common to both x and the positive 3. If I factor out the x minus 2, then what's left behind is what was sitting outside of each set of parentheses. I have an x and a positive 3. So x minus 2 times x plus 3 would be the factored version of the original grouping that was given to you in number 1. Looking at number 2, you can see that x plus 2y and x plus 2y are common to both terms. Before we factor that out, though, I have x times the quantity x plus 2y minus the quantity x plus 2y. You can think of this as having a 1 in front of it. So that when I remove the factor of x plus 2y, what stays behind to create the second binomial factor will be the x and the minus 1. So x plus 2y times x minus 1 would be the factored version of the problem above. Okay, looking at number 3, u plus m is common to both. If I factor out u plus m, then what remains to create the second binomial factor is the u and the minus m. Number 4, I almost have matching binomials, and here is where I have to force a match. In number 4, I have to force a pair of matching binomials. So I have x minus 4 and 4 minus x. I'm just going to recopy the first group of terms. If I factor a negative 1 out of the binomial 4 minus x, what that allows me to do is rewrite 4 minus x as negative 1 times x minus 4. If I distribute the green negative 1 back into the green binomial, you can see that I haven't changed anything. Negative 1 times x gives me the negative x, and negative 1 times negative 4 gives me the positive 4. So I haven't changed the value of the problem. I'm just simply factoring out a negative 1. And now what I've done is I've created a match. I have matching binomials in the x minus 4. So if I write x minus 4 one time, then the binomial factor that goes with that would be the x minus negative 1, or simply x plus 1. Looking at number 5 is exactly like number 4. You can see that I have m minus 2 and 2 minus m. If I could create matching binomials here, then I could factor that out. So let me recopy. And now what I'm going to do is take this term 2 minus m, factor a negative 1 out, and write that as m minus 2. And what that allows me to do then is take matching terms of m minus 2, remove them, and then what I have left over is u sitting right here. But I have the plus 5, but I've now multiplied that times negative 1. So instead of that being plus 5, that now becomes minus 5. So the factors are m minus 2 times u minus 5. Number 6, same problem type again. I have x minus y and y minus x. If I copy 7 times x minus y with the addition sign as it's given and the y, but now I'm going to factor a negative 1 out of this term, which allows me to then write it as x minus y. And if I check myself, negative 1 times x gives me negative x, and negative 1 times negative y gives me positive y. So I have not changed the meaning or changed the value of anything. My common binomial factor is x minus y. And then what's left behind is the 7 And I have a positive y here, but I'm multiplying it by a negative 1. So what I really end up with is a negative y. The operation has changed. So x minus y times 7 minus y become the binomial factors for number 6. So let's go back to 4, 5, and 6 and do a more efficient method with this. I know I need to create a match here with x minus 4 and 4 minus x. When I factor a negative 1 out of the binomial 4 minus x, the only result that I feel is simply changing the operation that connected the two terms. If the operation is subtraction, when I factor a negative 1 out of this term, that operation becomes addition. So a quicker way to think of it, I have my first term. If I change the subtraction sign to an addition sign, it allows me to just go ahead and rewrite that second binomial as x minus 4. So now I have my matching pair, and then what remains behind is x plus 1. Looking at number 5, the same thing. I'm connecting the two terms with the operation addition. If I factor a negative 1 out of 2 minus m, that allows me to just change this operation from addition to subtraction. That's the end result that I would feel there. So if I recopy it like this, changing this to subtraction, and then just simply writing this as m minus 2, I now have matching binomials in m minus 2. So I factor those out, and then what's left behind is u minus 5. Just a little bit quicker way to do this. Let's do number 6 this way. The two terms are connected by the operation addition. If I change the operation to subtraction, it allows me to rewrite y minus x as x minus y. And now when I'm factoring, I have the common term of x minus y, and then what's left behind is 7 minus y. Just a faster way to get the same result.